find the area of the region bounded by y equals sine x, y equals cosine x, x equals 0, and x equals pi over 2. Okay, so we're going to start by looking at, we want to graph our region. Right? That's always what I want to do. I want to get a picture of my region. So these last two equations, x equals 0, x equals pi over 2, tells me I'm looking from 0 to pi over 2. That's my region that I'm looking between. And then I have these two other functions, sine, cosine. We want to see where do they intersect. So we're going to repeat our process before on the last example, find their intersection points. So let's find their intersection points. How did we find intersection points? Set them equal. Set sine of x equal to cosine x. And then you might think, oh no, I can't solve for x. It's okay. What does this equation say? It says sine is equal to cosine. Where does that happen? At what angles on the unit circle are sine and cosine the same value? Pi over 4. And then there's another one too, but remember I'm only looking between 0 and pi over 2, so I only care about pi over 4. There's also, I think the other one is 5 pi over 4, but that's outside of our range, so we don't really care about it. Okay. So pi over 4. So at pi over 4, so halfway into this interval, they're the same value. Okay. So I know where they intersect, so let's start by graphing these functions. Okay. So sine starts off at the origin. Sine starts off at the origin. At pi over 2, it's 1. At pi over 4, it's square root of 2 over 2. So it looks like this. That's what it looks like. And then there's more stuff there, yeah? And cosine, so this is sine. I'm going to remember that. Cosine starts off at 1, and then it has square root of 2 over 2 is at pi over 4. Pi over 2, cosine is 0. So cosine looks like this. And I wanted between 0 and pi over 2. So it looks like my region that I'm trying to find the area of, it's these two, let me draw this dotted line up here. It's these two pieces right here. So I'm going to call these regions some names. Let's call this first one A1 and the second one A2. Come on. A2. So to find the total area, A, I need to add up the area of that first region plus the area of my second region. And then we'll write down our first region. What are my bounds on x for my first one? 0, and then pi over 4. And now I've got to figure out which function's on top in that first region. I didn't label it. I want this top function. Which function was that? Was that sine or cosine? Yes. We wanted 0, so it was cosine. Okay, so my top one is cosine. And my bottom one is sine. So that's the area of the first region, plus, now I need to find the area of the second region. Well, my bounds for x, it starts at pi over 4, and it goes to pi over 2. And they've switched places now. Right? My top function is sine of x, and my bottom one is cosine. So you'll write, it'll be sine x minus cosine x dx. Okay. And you'll compute each one of these. And this isn't too bad. These integrals are not all that difficult. You just have to remember your trig. So you get sine plus cosine plus negative cosine minus sine pi over 2. Okay. You plug in the top number, sine of pi over 4, root 2 over 2, cosine of pi over 4, root 2 over 2, minus sine of 0 is 0, cosine of 0 is 1, and then do the same thing for the second one. You plug in pi over 2, you'll get cosine is 0, minus 1, and then minus, it'll be negative root 2 over 2, minus root 2 over 2. There we go. And you simplify, this will be the square root of 2 minus 1 minus 1 minus plus square root of 2, 2 square roots of 2 minus 2. Okay. Okay, something I want to mention to you, I want to make sure I do this. Let's go back to our picture. If I've drawn this in a good enough way, hopefully I have, you can see that A1 and A2 are symmetrical. They really, if I fold in half at my intersection point and line them on top of each other, they would be identical. So what you could have done is just find the area of one of these regions and then doubled it. Okay? So if you wanted to, I want to make sure and do this and tell you. Another way to find A is to compute the first integral, which was from 0 to pi over 4, cosine minus sine, and multiplied that by 2. And if you compute that out, you should get the same exact answer we got, 2 square roots of 2 minus 2. Okay? Right, so sometimes in a lot of these problems, depending upon your region, you can make it a little bit easier on yourself if you use symmetry that's occurring in your graph, in your picture.